Hello everyone, welcome to lecture series on linear differential equation and their solution. In our today's video, we are going to learn shortcut method for finding particular integral in certain standard cases. Okay, for similar videos, you may have to check in my playlist. Okay, without further ado, let's get start our today's lecture with the shortcut method for finding the particular integral. Now see guys, for finding the particular integral, there is not only a single method that you can use, a general method that I explained in my previous lecture. Also you can use the shortcut method that you will get the very easy solution. So today I'm going to explain shortcut method in our channel. And also one more method is there for finding a particular integral. We use a variation of a parameter. That one is also very much important in the perspective of your GATE exam also and your competitive exam also. Okay, so that remaining part we are going to see it later on. Right now we are going to see a shortcut method for finding the particular integral. So in our shortcut method we have to remember some results. Okay, so in order to solve a given particular integral, okay, so we need to remember some shortcut to solve this particular integral. Now see that we are going to solve shortcut like whenever we have exponential function like e to the power something, like a trigonometric function like a sin x, cos x, or hyperbolic function like a sin hyperbolic x, cos hyperbolic x, or you will get the power function to the power x to x raised to m or y raised to m. In such a case, we are going to apply directly shortcut method for finding the particular integral. Okay, now let's go for some of the shortcuts here. So first shortcut I am going to use it for exponential function. Okay, whenever we have function f of x as a e raised to ax. Okay, so we are not going to consider f of x as a phi of x is e raised to x. Okay, so what we have learned the particular integral in our last lecture. So particular integral can be written as 1 upon f of x, 1 upon f of x into phi of x. Okay, 1 upon f of x into phi of x. So f of x, it is an auxiliary equation from our left hand side of differential equation. Phi of x, it is the right hand side, okay, which is from linear differential equation. Okay, so whenever you have such a condition, particular integral, okay, in our general case what we have done here, we applied some of the result here, 3 standard result, and then we proceed for the solution. But now see that guys, see that here guys, we have this one is quite lengthy and time taking process. So I feel that we have to apply in some case shortcut also. Okay, and don't worry about that. If you are going to apply shortcut method for finding the particular integral, you will get the out of marks. Okay, it's not that necessary that you have to solve the question using only the general, okay, method. So you can apply this shortcut method also, or you can go for variation of parameter also. Okay, now see that whenever we have such a particular integral 1 upon f of x into phi of x. Okay, so now we consider here phi of x as a e raised to x. Okay, and x we replace in the form of a d. Okay, so particular integral, how it look like then 1 upon f of d. Okay, f of d means we are getting the auxiliary equation in the form of like a d square plus 2d in such a form. Okay, so that means our given auxiliary equation in the form of a d. So I written as 1 upon f of d into phi of x. Now phi of x I consider here e raised to ax, e raised to ax I consider here as a phi of x. Okay, yes, now whenever we have particular integral 1 upon f of d into e raised to ax, now see very carefully, it is very easier to solve our given particular integral. Now see that what we have here, e raised to ax, na, that means we have the exponent to the power a, constant term it is a here. Okay, so replace that constant term instead of d, replace that constant term instead of the d and keep e raised to ax as it is, don't change anything here. Okay, so what we will get here, 1 upon d replaced by a. Okay, so we write 1 upon f of a. Okay, 1 upon f of a, and e raised to ax keep as it is. This one is our required particular integral. Now see that how easy the solution is. Just only in a 2 step we found the solution. Oh, it's not that difficult. Just need to replace the value. Be careful with the value of a d and a. Okay. Now, for example, if I have d square plus 2d, okay, 1 upon d square plus 2d and e raised to 2x. Just for your understanding of this shortcut, just consider this particular integral. I consider this one as the example. Okay, 1 upon d square plus 2d e raised to 2x. Okay. So what we do, we have the value for a which is a 2. So replace a as a d. Okay, that means d as a 2. That means a which is equal to 2 which is equal to 2. This value you have to replace it here. So we are going to write this one as 1 upon 2 square plus 2 multiplied by 2. So what I have done here, actually we replace that power 2 instead of a d. Okay, so d it gets to the 2 and that d it gets to the 2 here. So 1 upon 2 square plus 2 into 2, and then go for further calculation. You will get the directly particular integral. Only in a one step we are getting the solution. Okay, so these are the shortcut, very much important for your exam, that you can get the very easily answer. Okay, yes, but we have one more condition here. What happen if f of a goes to 0? Now in mathematics we know that whenever a denominator it goes to 0, that quantity it will be like it tends to the infinity, and we are not dealing infinity terms in our regular calculations. Okay, try to avoid infinity term from your calculations. Okay, so that means we want f of a which not equal to 0. We want f of a, how we want here, not equal to 0. Okay, but what happen if denominator goes to 0, if f of a is 0? Okay, then we arise here first condition or first case, if f of a which is equal to 0. Okay, that means that denominator it goes to 0. Okay, so that means we have to go for little extension, like little generalization in our particular integral. Okay, so then we write particular integral 1 upon f of a into e raised to ax as multiply numerator x. Now see that this one is also secondary. Multiply numerator 1 to the x, it remain x, and f of a it is here now. Then take f dash of a. That means you have to, so instead of a take it d. Okay, first of all find out the f dash of d and replace a e raised to ax. Okay, this one is our required particular integral. Okay, now see that it's very much easier. We need to multiply x to the numerator and take the derivative of a denominator and keep e raised to ax as it is, as we have done in a yellow hospital rule. Okay, so I hope you all are familiar with these conditions. Okay, now but even after, what happen if f dash of a it goes to 0? Okay, then it tends to again infinity, but we do not want infinity here. Okay, so we have one more condition, that f dash of a not equal to 0. Okay, but what happen in second condition, if f dash of a which goes to 0, what happen if f dash of a it goes to 0? Then we write 1 upon f of d into e raised to x. Okay, into e raised to x as a x it is there. Now again multiply x by x, we get the x square, and take double differentiation of denominator and to replace the value of a, then we get the e raised to ax. Okay, and f dash of, provided f dash of a need to be not 0. Okay, so now see that how easy the solution it is. Okay, so we are going to apply this shortcut method for our subsequent example. There are another methods also. Method means for the sine, cos, hyperbolic or trigonometric function. There are some another conditions. I will explain these ones, but after some examples. Okay, now we understood here the shortcut method. Now we have to apply that shortcut method for some examples. Okay, let's do it now. We go for some of the example using shortcut method. Okay, so I consider here, let me consider one of the example here. Okay, so I will consider one of the example here. Okay, so I consider this example here, d square minus 5d plus 6 into y which is equal to 3 e raised to 5x. Okay, now see that for finding the complementary function it is easier. Okay, that one I'm not going to explain here. So if you wanted to see the complementary function, how can we find for such examples, use my previous videos. Okay, you will get the proper answer there. Okay, yes. So find out complementary function by yourself. Okay, I'm not going to explain, as I already explained in my last lectures. Okay, now we are going to proceed with the particular integral only using shortcuts. Okay, we are going with the shortcuts and going to find out the solution for our given linear differential equation. Okay, now see that what we have other side here, 3 raised to 5x. That means phi of x, it look little similar like e raised to x. Okay, it look little similar like e raised to x. Okay, let's go for finding the particular integral of our given linear differential equation. Okay, so particular integral can be written as 1 upon f of d into phi of x. Okay, 1 upon f of d into phi of x. Now we know that f of d, we are taking these terms as a f of d only. Okay, so 1 upon d square minus phi of d plus 6, d square minus 5d plus 6 into phi of x. Phi of x means this one is the complete right hand side, so we write a 3 raised to 5x. Okay, this one is our complete right hand side. Now see that this one is our particular integral. We have to solve this one. So you can solve using generalized method also, but it is quite time taking. So as we are learning shortcut method, just focus on the only shortcut. Okay, yes. So whenever we have 3 raised to 5x, that means we have to concentrate here. Where we have e raised to x, that means we replace that a instead of a d. Okay, replace a instead of d. Okay, I'm going to replace a instead of d. Now what is the value for a? This gives a which is equal to 5, e raised to ax. Ax means e raised to 5x. Okay, that means the value of a, I got it here 5. So replace a as a 5 in our given denominator. Okay, this d as a 5. Okay, that means a and d both are equal here. So how I'm going to write here, 1 upon 5 square minus 5 multiplied by 5 plus 6. Okay, and which is having phi of x 3 e raised to 5x. Don't need to change anything here, keep as it is. Okay, and what is the last step then? Particular integral can be written as 3 divided by 5 square, 25, minus 5 5 is 25, this becomes 0, and then 6 only the part of denominator, and 3 raised to 5x. Okay, sorry, 3 I taken out here. Okay, that 3 is not coming again, that 3 I taken out here. So divide by 3, we'll get the 1 upon 2 e raised to 5x. Okay, this one is our required particular integral. Now see guys how easy the solution it is. Okay, so if you are going to write this solution in your SPPU exam, you will get the out of marks. Okay, so it is also correct. You can apply generalized method or you can apply regular shortcut method also. Okay, so generalized method, we go for finding the factor and we use the result 1 upon d plus a into phi of x, 1 upon d minus a into phi of x. These methods these results we apply here for finding the solution. Okay, I hope you all have understood this example. It's only for particular integral. So if you want to find out the complementary function, go for it and go for the general solution. General solution, it gives complementary function plus particular integral. Okay, find out the general solution and let me know in my comment section. Okay, yes. Now what we have done, we found here the particular integral whenever denominator is non-zero. Okay, now let me consider the example in such a way that denominator goes to 0. So our second case, it will be crystal clear for us. Now see guys, here I have next example. Okay, that example will clear our next case whenever we have denominator 0 or non-zero. Okay, we'll see it later on. Just let's go for finding the particular integral using our given example. Okay, so particular integral, we know that 1 upon f of d into phi of x. Okay, so in order to find out the f of d, first of all find auxiliary equation. Okay, auxiliary equation. We are going to find out the auxiliary equation. So we are going to write d square, double derivative means we are going to take it as the d square plus 4 times d plus 3. Okay, y out here common, a raised to minus 3x. Okay, so how I have written this auxiliary equation, I already explained in my previous lectures. go and observe them. Okay, I'm not going to explain that one here again. It is quite easy. Okay, that is a double differentiation. Just I'm replacing d by dx as a capital D. Okay, if double differentiation, that means d square. Okay, yes, so I got this one. Now what we do next? First we go for finding the particular integral. Okay, what is the auxiliary equation? D square plus 4d plus 3, which is equal to 0. Okay, this one is our auxiliary equation. Okay, so particular integral can be written as 1 upon f of d into phi of x. Okay, this one is our required particular integral. Now f of d is here, d square plus 4d plus 3. Okay, replace here instead of f of d. So we are going to write 1 upon d square plus 4d plus 3. Okay, 1 upon d square plus 4d plus 3, and if phi of x, which is a e raised to minus 3x. Okay, that I replace here phi of x directly, the value. Okay, e raised to minus 3x. So what is the value for d? This one is our particular integral. Okay, what is the value for d? The value for d is a. Okay, value for d which is equal to a, and a which is a minus 3. Okay, we compare this one with the e raised to ax. E raised to x, the value for a which is a minus 3. Okay, so d which is equal to a which is equal to minus 3, replace here in a particular integral. Now see that what we get here, particular integral, it is 1 upon d as a minus 3, so minus 3 square plus 4 multiplied by minus 3 plus 3. Okay, into e raised to minus 3x. Keep this term as it is. Okay, now see that, go for next calculations. So I can write this one as 1 upon minus 3 square, 1 upon 9. Okay, plus 4 into minus 3, 4 3 is a minus 12. Okay, minus 12 plus 3. Okay, so 9 plus 3, 12, 12 minus 12, it goes to 0. Now see that we are getting denominator as a 0, and we do not want denominator as a 0 here. Okay, so in such a case, what we do, we multiply numerator as a x and going to take the differentiation of a denominator. Okay, that one is our required solution then. Okay, yes, let's go for adjusting the terms. Okay, so how can we find the term that we have to multiply x and take the denominator? Okay, see that 1 upon f of d into e raised to x. Okay, so that denominator gives us the value 0. Okay, which is 1 upon 0 into e raised to minus 3x. Okay, that gives us denominator 0. So in such a case, what we do, we are going to change this particular integral. Okay, what we are going to do, we are going to change this particular integral. Okay, using our second case. Now see here very carefully what I am doing here. Okay, I am writing particular integral as multiply numerator x. Okay, multiply numerator x, 1 into x, I am going to write it as the x. Okay, take the differentiation of a denominator. Okay, denominator differentiation means d square, and take the differentiation with respect to d. So you will get the d square differentiation 2d. Okay, again 4d differentiation with respect to d, which is a 4. Okay, and again constant 3 differentiation, it is 0. Okay, multiplied by e raised to minus 3x. You don't have to differentiate this one. Okay, x multiplied by f dash of a d into e raised to x. Okay, this is the standard result. Now replace the value. Okay, replace again the value of a. So as we can see, a is a minus 3. Replace it here. So x divided by 2 multiplied by minus 3. Okay, 2 multiplied by minus 3 plus 4 into e raised to minus 3x. So what we write next step here, x multiplied by e raised to minus 3x total divided by 2 3s are minus 6. Okay, it is a negative 3 here now, so 2 3s are minus 6 plus 4, so minus 6 plus 4, which is a minus 2. Okay, this one is our required particular integral. Now see that how easy the solution it is. Okay, I hope you all have understood. Okay, you all have understood my first shortcut method with the examples. Now see that how easy this type of the solutions are. Okay, and this example gives us 4 marks, gives us the 4 marks in your SPPU exam. Okay, don't forget such a easy examples that will help us to get our score higher. Okay, so that is here for my next example. I explain first shortcut method with some of the examples. Okay, yes. Okay, I hope you all have understood everything here in my today's lecture. Even after, if you found anything difficult, doubtful, or anything it is there, anything means anything, let me know in my comment section. I will come up with the similar videos. So if you have any other complicated example, like a challenging example, let me know in my comment section, guys. I will come up with the solution. So thank you everyone. Thank you for my today's lecture.